Hi, can you guys hear me? Okay, awesome. So let me get started. Okay, let's this and okay. So in this session, I'm going to take you over how we can create an Alexa skill on Java using Java on AWS. So we will begin with understanding the requirements as to what are the different components that are required and what. But first, let me just check. Are you able to see my? I hope you're able to see my screen. And can you respond, Balana or someone? Okay, awesome, awesome. Thank you, thank you. Okay, so we will begin with understanding the requirements, and from there we will proceed understanding how we can create a skill interface, and then skill interface do need a Lambda function working behind the scenes, so we create them as well on how to handle intents, and then we will see how we can extract the data from the voice commands that the user has given with the help of slots. And finally, we will use DynamoDB to process the data into the DynamoDB so that we can respond based on the history of the user. So before we go ahead with the session about me, right now I'm an SDE in Amazon. So earlier I have worked with Oracle as well as IBM. And so I have my areas of expertise are typically AWS, JavaFX, and initially I began as a test engineer. So test automation was also an important a skill that I've worked for quite a long time. And I'm right now leading Java user group Hyderabad. So if any of you are from Hyderabad, do join the meetups there. So before I go ahead, it's a disclaimer. I'm not representing Amazon to you, and I'm not a developer of Alexa team. So even though I'm from Amazon, there can be some aspects that I'm wrong because Alexa will be making lots of changes. So please do keep that in mind. Okay, so let's get right away started to what Alexa skill is and how it does work. So you might have already heard about Alexa, Echo, and you might have seen them in Amazon's website, etc. But those are not just the devices that you can actually use to use Alexa. You can use them in any mobile app. You can even if you can create an Android app where you can actually integrate an Alexa skill. So we are not going to touch upon all that, but we will whenever I'm talking about whenever I say Echo or anything, just understand that it's a common generic term for any Alexa-enabled device. So how does it work? So usually there is a user, maybe me or you. You may be speaking some voice commands to the Echo, which will be passed on to Alexa voice service, which will actually pass that information to a Lambda function. Alexa voice service does do some things, which we will get into a bit. Even before we that, let's just get a bird's eye view of what all happens. So Alexa voice service does some magic and identifies which Lambda function to execute, and it calls the Lambda function. If you are in AWS world, but it's not required that you always have to write the code that is required for Alexa service in AWS. You can also have your own HTTPS server that can be configured so that Alexa voice service can identify it. So typically there are three different areas, right? One is Alexa enabled device where user is speaking. That's all happening in home of the user. And then the Amazon Alexa voice service actually is configured in Amazon Dev Portal, which I'll show you how to do and all. And service endpoints can be anywhere you want. They can be either AWS Lambdas or any place. You can even deploy them in Azure as long as you are able to expose that particular server's IP address or something so that Alexa voice service can interact with it. So remember that it has to be a HTTPS endpoint, otherwise it doesn't support HTTP. So let's get a bit more technical. So I just gave you a very high level overview of it. So typically a user gives a command, and that command will be listened by the Echo or any Alexa enabled device, and it tries to pass on that information or whatever textual whatever voice command we have given as an audio file to the cloud. So this is where Alexa service comes into the picture. It tries to understand what is your intent. Okay, and once it understands your intent, it will try to call the respective Lambda function, and the Lambda function can in turn call any database like DynamoDB, or if you kept your database in some Firebase or some other database, it can call that, and you can also call the log. You can also log the information in CloudWatch. So it all depends upon what kind of endpoint that you have created. And once the Lambda function has worked its magic and it fetched the data that it wants to send back the user, it sends the textual response, like typically a string, to the voice skill. So whatever skill we have configured, from there it comes to the Alexa voice service, where a response card will be prepared and our text will also be converted into audio. And if our our skill has some video or some other thing to be displayed, it appropriately converts all that information, or assembles every information that is there. And once Alexa prepares that information response, it is sent back to the Alexa enabled device. So if the enabled device doesn't have any display, it will simply read out whatever information that has been there. And if it is it's like, if it is something like Echo Show, it will also display a card. Eventually, user can get to listen to that response, and hopefully he's happy, assuming that we have developed our skill right. So in this demo, we will try to touch upon all these areas so that you get a full understanding of how everything works or everything ties together. So what's the process to create a skill? So typically we create an Alexa skill in developer portal. When I said when we create a skill, we simply create an interface or a placeholder where we actually write intents. Intents are something, okay, intent is short for user intention. So user may want to ask the Alexa to do something. Okay, maybe he wants to know this weather. Maybe he wants to know the traffic on his way to office today, or maybe he wants to listen to his favorite music, or he may wants to add some list of items to the to-do tasks that he wants to add to. So all of these are intentions. Okay, however, what is the problem with audio intentions? User can tell it in any number of ways. You can say, what's the weather today? Or you may also be thinking like saying, how may be the weather today? How is the weather today? Will it rain? Etc. etc. So user can definitely say tell the same intention in wide varieties of ways. Our Alexa service will try to understand what the intent is. It tries to map to a specific intent. Okay, and then it tries to extract some data that is important to the skill to work. So as you can see, the intent in this particular example is what is the weather is an intent, tell me the news is an intent, add to my shopping list is an intent, and adding to a to-do is an intent, and play music is also an intent. Okay, from then on, slot identification comes into the picture. What is a slot? A slot is a data that can vary. Okay, for example, take this example of what is the weather today. There, a user can say what is the weather today, or he may say what is the weather yesterday, or what will be the weather tomorrow. So that's a variable. What is the weather is an intention that's going to be fixed. Even though he may say it in wide varieties of ways, it is still, the intent is still fixed. But what exactly he wants to do with that intent or was fine-grained. Once if you are asking the Alexa to play some music of, say, Ilayaraja or Michael Jackson, maybe the Michael Jackson or Ilayaraja is the variable data that user is passing along with the intent. So that is what is called as a slot. So we also configure slots in Alexa Dev Portal, and so that we can extract the information from the command that we have received from the user. And then we will configure interfaces. Like, what do I mean by interfaces? Interfaces can be something like there are some responses that are purely textual. User will not listen anything. User will only see some card, or maybe he will see some response. But if, say, for example, we may have to play music, or we may have to play some audio, or some other thing may have to be displayed along with audio. So that's what interfaces are. Like maybe along with the textual information that we want to play it as text, play it as audio. We may also want to play some music or something like that. So that's when we can configure different kinds of interfaces. But we will not touch upon interfaces because I don't think we will have enough time to cover the topic of interfaces. We will simply see textual responses and cards, how we can display those things. Okay, once we are done with the work that we want to do in Dev Portal, our work is only half done. Then the next segment that we have to complete is configuring the endpoint. As I said earlier, endpoint can be a Lambda function, or it can be a traditional HTTP server where you have created your service as to how it can respond. Maybe it can be a REST API, a REST endpoint, or something like that. But in this demo, we will only look at a Lambda function so that we can finish the end-to-end cycle within this time period, stipulated time period. So once we have configured, what do I mean by configuring the endpoint? Configuring endpoint means telling the Alexa skill where it can find the Lambda function. So it's just that giving an ARN, or if you are aware of AWS skills, they have a ARN, which is a resource name, which is unique for every resource in an AWS service. If it is HTTP endpoints, you may have to provide the system address, port, and what is the name of the REST endpoint, etc. And so while creating the Lambda function, there are specifically three things that we will have to take care of. One is we have to develop the Lambda function, which can be written in any wide varieties of programming languages: Java, Python, JavaScript, C#, Go. I think there are a few more, but I don't want to list all of them. So once we have developed the code for that, we can deploy the Lambda on the AWS Lambda. And we may also have to give required permissions, like say, for example, if we want to access DynamoDB, we may want to give our DynamoDB access to the Lambda function. So once we have done everything, then we will be able to execute the Alexa skill from a test service. Okay, we will not use. I will not use the actual Alexa device because I'm showing you a demo. So it is very quick for me to test it in the Alexa console itself, which I'll show you how. So we will not be using the actual Alexa device, but the process will be very similar. So in this demo, I will first create the skill interface, and then we will develop Lambda for simple intents, and then we will see how we can actually use slots to extract data, and then we will also use DynamoDB to persist the data. Okay. And once we have completed the demo, if there is time, I will try to show a little bit more, but I don't think we will have. So let's quickly jump to the demo. Hopefully there are no questions. Let me just check. Okay, there are no questions. So let me get started on the demo part. Okay. So creating a, okay, even before I come to the code, let me just open the Alexa console. Alexa. So it can be accessed from developer.amazon.com. From there, you may have to sign in. So you will have to configure. If you already have an AWS account, you can very well use that information. Otherwise, you can create one new developer account as well. And to complete the demo, you will also need to have an AWS developer account, which you can get it for free. Like all the stuff that we are going to do today are going to be free of cost, in the sense like uses of DynamoDB or Lambdas. We will not be reaching any free usage limit. So we are fine there. So now when I open this and click Amazon Alexa, I'll be taken to Alexa console. And in here, we will be able to create different skills. So let's click on skills here from the your Alexa consoles. Okay. So if you see, it is already listing me several skills that I have tried or created earlier, or the ones that are being under certification by Amazon. So if it gets approved by the Amazon, it will go into the Alexa skill store, where others can actually search for it and actually use it. Okay, let's not, but it will take a couple of days before it can get approved. And if there are more, it may take even more time. So we may not be able to complete the certification today, but I will show you how you can trigger the certification. So first and foremost thing, we have to create the skill. So let's create a skill. Let's just call it a demo. Okay, let's not make it any complex. And next. It will bring up a place where a wizard where I can select different kinds of what kind of Alexa skill I want to create. Do I want to create an Alexa skill where I want to display some video, or is it a flash briefing, or I want to create an Alexa skill that can actually interact with some smart home devices, like you may have a lights where you can call Alexa. You can create apps like wherein you can turn off lights of different bedrooms, etc. once you configure it. Today we are not going to go over all of that. They are slightly complicated than the default one we are going to see. So I'm going to select the custom. And once I did, I can click on create skill again. You may be wondering that there is lots of information here, but the things are very simple. You simply have to fulfill this checklist. Whatever checklist you can see over here, you will be able to quickly get through all of them. So first thing that you have to give is you have to give a skill invocation name. Okay, how do you ask Alexa to use your app? That's what a skill invocation name is. Let's just give it as demo and see if it allows that. Okay, and save. And then, as I said in the PPT, once we have created an invocation, the next thing that we have to do is we have to create intents. Okay, creating intents means all I have to do is I just have to click add here. I'm going to create a hello demo intent, and I'm clicking create custom. There are lots of default intents that you can actually build, but let's not go into that at this point of time. So hello, so this is an intent that we want to create. How can user call this intent in a wide varieties of ways? Let's say he can simply say hi or hello. It's not that we have to give all kinds of intents that we want, all kinds of ways the user may invoke. We should give as many as possible so that Alexa will try to come up with a pattern. So even if the user says it with a slightly different wordings, etc., it will try to map to some or other intent. Okay, so let's just say hello and hi. For now, let's not do anything else. Let's just build the model. Okay, while the model building is in progress, let's get into the other aspects of the creation of Alexa skill. So if you go to interfaces, you can actually enable if you want audio interface, or do you want to display a video or anything else. For now, let's not worry about any such interfaces. Let's create simple skill. And finally, we will have to create an endpoint. Here you can choose whether it's a HTTPS endpoint. If you click here, it says what's the URI, some ways to actually reach to the particular endpoint, whatever you have created. And this demo, we are simply going to create an AWS Lambda ARN. So let's create that. So in this, we have to give ARN for the Lambda, but we don't have any Lambda so far. So let's quickly create that. So for that, as I said, you will have to have a default account. You can very well create that for free of cost. You may be asked to give the credit card information just to make sure that you are a person who is not going to misuse it. Okay, so but there won't be any charges on your card, maybe 1 or 2 rupees. It's just INR, very small cost. So in this, let's create a function. Let's just call it demo. Okay, as our favorite language is Java, let's just select Java 8. And here we can choose an existing role, or we can create custom role. What is a role? Role is a way for AWS to give access to a specific components of AWS. Okay, here we are creating a basic Lambda execution policy. Sometimes you may have to have more access than what you get by default, but let's not get into that for now. Let's create a new IAM role. Let's lambda basic execution underscore demo, and let's click allow. And then that whatever role we have created comes over here, and let's click create function. So somehow we have to tie the AWS Lambda with the Alexa skill. So it's actually a two-way approach. You have to provide the skill ID to the Lambda function as well as Lambda functions ARN to the skill as well. The reason being security. You don't want a Lambda function to be misused for multiple skills. Otherwise, you will never be able to find out how it is getting triggered. So you will have to pass give the skill ID here. While doing so, you can also copy the ARN that is provided by the Lambda function that's created for the Lambda function and pass it on here. You can simply give it in the default region. If you create a region-specific Lambda functions, you can definitely use them. But for our demo, everything is same. So the error that we got is the Lambda function is not ready yet. So let's just first save the Lambda function. And now let's try to save the endpoint. Now it has successfully added that endpoint. Okay. Now let's just click test. So now I'm going to the test tab. So this is where you can actually test your skill. Okay. Please understand that we have not completed creation of Lambda function because we still have to write some Java code. So ideally we will be receiving an error, but how do we actually ask the particular skill to work? So we will have to type something like ask demo hello. So when we say like this, we may receive an error. I'm not sure if you can actually listen to the audio that has just come in my computer. Let me just see if I can. Okay, the output I want it in internal speakers, and now if I say ask demo hello and press enter, so this is there was a problem with the requested skills response. So because we haven't done any Lambda code, we are getting some error. That's expected, and hopefully you have heard that audio as well. And along with typing, we can also click the mic and keep holding it and ask the Alexa to perform something or other. Okay, so now I've spoke a lot of stuff, so I don't think it will be able to recognize it, but let's see. So it will be unable to identify that because we spoke a lot. So we can say something like ask demo hello.
Sorry, I don't know that one.
So it was unable to recognize that because we haven't configured. Along with that, it also captured a few other words. Okay, let's try ask demo hello.
There was a problem with the requested skills response.
As expected. So let's do the other part, that is creating the Java code for the skill that is required. So let's go to the build and make a note of the intent's name. We will have to give the intent's name in the Lambda function or the code that we are writing. Otherwise, you will know why. And as I was saying earlier, you will be able to see a checklist over here. That says whether we have completed all the steps or not. So let's quickly go to the Java code. And here, all you have to do to create a Java skill is you will have to create. You can create a Maven function, and you will have to add some dependencies to it. So let me just copy some dependencies from an existing project that I already created. So the only dependency that you have to add is the ask SKDK from group ID com.amazon.alexa. So the current version is 2.0.2, but you can very well check for the latest version. So there are two things that we have to create at minimum. One is a request handler for the intent that we have created. So the hello demo intent is one request. Whenever a user made a request, it may match this hello demo intent. For that, we will have to create a request handler. So let's just quickly create request handler, and it has to implement request handler interface. It is from com.amazon.ask. Dispatch.request.handler.request handler. So it will ask us to implement a couple of functions. Okay. Here we will have to return a predicate so that it can identify that this is the source code that has to be triggered for us that specific intent. So here we have to pass the intent name as it is. So the intent name is hello demo intent. We can simply copy paste that. Okay, so what's the error that we are getting here? So it is saying it is expecting a Boolean while we are actually passing the a predicate. So what we have to do over here is we have to identify whether it is matching a specific handler or not, which can be done using from the input dot matches, and we have to pass the predicate. So this matches is a function that will take this predicate and tries to find out if this is returning true or false. Okay, here is where we have to actually write the code. So let's not worry about complicating things. Speech text, and let's simply say hello from demo. And from here, we can build the response that we want to build, because it's a simple one. Let's not complicate by adding more features in the hello world function. So dot with simple card title can be demo, and whatever is displayed is speech text with speech text dot build. So now what we have done is we have created a request handler. However, there can be multiple request handlers. Some may be in progress. So we will also have to create a skill stream handler that tells what are all the intentions that are ready for consumption. So for that, let's create a skill stream handler code. So this has to, let me just copy some code that is already there. Stream handler extends skill stream handler. So it has to return a skill and extends skill stream handler. Okay, this I cannot name it exactly same. So let's just call it a stream handler. And this also has to be different one. So what we have to do is we have to create a constructor wherein we pass in a skill. A skill can be built using skills.standard, and we can add whatever request handlers that we want to add. And finally, we have to call the build method in order to be able to call the create the necessary skill. So let's rename the file. Let's name the file as stream handler itself. Now we are ready with our hello intent, hello world kind of intent. So what we have to do is we have to build all the packages along with the dependencies. We can do that by running the maven build with the goal, but we have to make sure that we have to run a different goal than default one. So we will have to build a jar with dependencies. So for that, we can very well run the build from the Maven. I just configured a default goal, so whenever I run a build, it will simply be creating a jar with dependencies. Because it's the first time, it will take a couple of seconds, I guess. So whatever jar this is generating, we will have to actually upload it to this Lambda function. So let's wait to finish the jar creation. And while we wait, let's open the Lambda function. How can we upload source code? So just have to click on this Lambda function name, and here it allows us to create upload a jar file. So let's see. Okay, the build jar is successfully created. So all we have to do is click upload, and we have to remember to select jar with dependencies. The default jar will contain only our classes, but this also contains all other classes like Alexa, request handlers, and all those stuff. So that's the reason why the file size is 9.2 MB. So once you have uploaded it, you have to click save. Along with that, we also have to provide it the name of the handler. So the name of the handler is stream handler. It's in default package, so we don't have to give anything else. Just give it as stream handler and click save. Okay, I clicked save here, and it may take a couple of minutes before it is ready for me to start using it. So let's just give it some time. AWS recently released some information related to local Lambda testing. So once you can actually explore that information, you will be able to test some Lambda functionality without having to upload them. But until then, every change that we make, we may have to actually create a jar file again and re-upload it and save it. So that's a default process that we may have to follow. Okay, I think it's ready. So let's go to the test. So we can ask demo hi.
There was a problem with the requested skills response.
So there can be multiple reasons why there can be a issue with the requested skills response. One, the Lambda function may not be ready yet. Two, there may be some issue with the code that we have written. So in order for us to be able to find out what is the issue that we had, we have to, because we are in AWS Lambda, we will be opening CloudWatch, which is where all the logs will go to. So let's open that so that we will understand the debugging process as well. Let's go to logs and demo. Okay, so now I'm opening this. We got stream handler class not found exception. So most likely the jar, whatever jar that we created, it didn't get created appropriately, most likely. Or let's just try it one more time. Maybe the service may not be ready as well. Let's demo hi.
There was a problem
Still
with the
there is a problem.
requested
So
skills response.
let's open this and okay, let's first see whether we have actually uploaded the right jar file. No, we didn't. We have uploaded a wrong jar file. That's the reason. So let's quickly go to the correct jar file. So now I hope you understood how I have debugged that problem. So it is saying the the skill handler class is not found, which will happen most likely when we missed out some class or if we have not uploaded the latest file, etc. This time, hopefully it will not take as long because it has already deployed that one. So it will be slightly faster now. while this demo is building, let us quickly create one more intent so that we can save some time later as well. So let's create an intent where we can save the read the information from the slot. So for that, we can create a new intent. Let's call it create note intent. So in this, we will be asking Alexa to remember some note. So remember that, say, do not forget that, note that. So user may say something like this: note that, do not forget that, remember that. But he will also give some note to remember, note for our app to remember. So for that, we can create a note slot. A note, it's just like a variable that we can actually create. Note as well as note. And in all those cases, user may say like, note that I have to buy groceries tomorrow. Do not forget that my watch is not working. So all that kind of different kinds of usages we can give, and whatever variable we are giving, that will be captured in this slot. So whatever slot we have created, it will be listed here. We also have to select a type of slot type. So because it's a variable text, we can select something like search query. Save model. And we can also test the skill. Let's click build model meanwhile. So while this is building, let's see if we can actually test our Lambda function.
Hello from demo.
Okay, as you can see, whatever we have coded in our hello demo intent request handler, that has come in as the audio response. Okay, the way it works is Alexa skill will create a JSON, and it will simply expect this JSON back. So our Lambda function will make sure that it parses the request that we have passed in and tries to identify which Java file it has to call, and then it tries to do the subsequent parts. So now, as we were able to create the hello demo, let's now create the intent on how we can actually save the notes from DynamoDB database tables. So I hope you are already aware of DynamoDB, so I'm not going into them because that's not relevant, but it is important for our demo. So I've created a table here. DynamoDB is like any NoSQL database like MongoDB or something. So here I've created certain attributes. Let me delete this so that you will be aware of any data that we add later on. So we'll be using this demo notes table to save the data, whatever the user is asking us to remember. So the note name is create note intent. So we can follow the same process. So we will have to create note intent request handler. We will have to give the exact text so that our Lambda function can actually execute this code. Now I don't have enough time to cover all this stuff, so I'm going to copy the text, so the source code from the previous one. I'll explain that. Just give me a moment. Remember note handler. Okay. So along with that, I've also created some source code. So here I've created a DynamoDB helper. So DynamoDB helper. It's a singleton class which I'm using to actually create connect with the DynamoDB database. So if you open that, you will find several commented out codes. So let me just uncomment that. It's a default how we can actually use DynamoDB in Java. So I don't know, that's out of the scope for this particular course. So what this particular class helps you to do is it helps you to connect with the DynamoDB database. So whenever we create an instance of this, it will try to make connections to the DynamoDB. And whenever we call, say, for example, mapper.save, it will try to save that object in that database. So let's just uncomment the create note as well, and some imports. And then we also have to store a specific item in the database. So which is what note item is. So let's just uncomment the code. So there are some attributes as well. And these are all default how DynamoDB is used. So let's just give the table name, the attribute, and also whatever value we store in user ID will be stored in this user ID attribute, which is nothing but user underscore ID. And we are saying that this note item will be inside the demo notes table. The same way text attribute, time attribute is timestamp, which whatever value is there in this time attribute, it will get saved. Okay. Now in the DynamoDB helper class, I have this create note method. What it is doing is it's creating a new note item object, and we are setting the user ID. We are getting the user ID from this session. So whenever Alexa Lambda function gets called, what we are getting is we are receiving an input. From this input, we can extract the session by calling the get request envelope.get session. And from that, we can actually get intent request, from which we can get the actual intent, and from which we can actually get various slots. So because the name of the slot is note, we are asking it to give me the slot named note. And we are also trying to fetch the value from it and storing it in string, a note. And what I'm doing is I'm calling the create note method, passing the session and note. So from session, user ID will be fetched and saved in this user ID attribute, and a new timestamp will be created, and mapper.save note item. So this will be simply saving the database, sorry, saving the value in the DynamoDB. Let us just, before I explain any further, let's just extract the create the jar file and upload it. So I'll have to click on demo and upload. And it's not created yet, still in progress. Now 8 KB. .2, which means the jar creation is complete. So let's upload it and save it. Okay, we will now going to be receiving an error. Why? We did create a new intent, but we did not tell our stream handler to about this new intent handler that we created. So now our Lambda function deployment is not going to work anymore. So we will get unidentified scale intent error in the CloudWatch log. So we also have to do this, and let's generate the jar file again. Okay. Along with that, we have not changed any other text, but we will be essentially saving the note in the database. We can say something like noted. I'm going to remember something like this. So this will be sent as a speech text backward, so that user will know that, okay, my note has been saved. So let's just quickly see, wait for the jar to be completed, jar to be created. And because the previous deployment is still in progress, we may have to wait for a moment. Okay, let's upload again and open, save. So while this is in progress, let's try to test and see that error that we get. So the way we ask is, remember that is the word that we have to use. So let's just call. Ask demo, remember that I have to buy some groceries tomorrow.
I'm not quite sure how to help you with that.
The reason we said ask it twice, so it still is not intelligent enough to ignore some of these things, especially the test console. So ask the demo to remember that I have to buy groceries tomorrow. We will still get error because the Lambda function deployment is still in progress with the latest code.
There was a problem with the requested skills response.
As expected. So let's go to the CloudWatch and refresh it and open the latest log. As you can see, the logging is still going on. Now, as you can see, it printed requested skill unable to find the suitable request handler. So as the deployment of the previous save was not completed yet, it did not find that. So let's try to copy this and paste it here. We may still get error. I'll explain you why, but let's just get the error.
There was a problem with the requested skills response.
So let's see what the problem is. Okay, now as you can, when you expand this, you can see that our role is not authorized to perform any insert or update in our DynamoDB table, which we can do by going to IAM roles and add that additional permission for the role that we have created. Roles, and the role that I've just created is Lambda Basic Execution Demo, and attach policy. Here I can for now I'm going to give full access for DynamoDB and attaching the policy. Let's just try the same thing again.
Hello from demo.
Okay, as I said, we did not change the text, so hello from demo is expected. But let's go into the database and see if something has happened. Yes, it did. So if you open this, you'll be able to see the user ID, timestamp, and I have to buy groceries tomorrow in my DynamoDB database. Let's just try something else. Ask the demo to remember that I have forgot time.
Hello from demo.
And in the DynamoDB database, we'll be seeing another item. So this is how you can actually persist the data from the database. So if we had actually pushed the latest code that we have, whatever we have done, we could have simply, it would simply say that noted, I'm going to remember that I have to buy groceries tomorrow. And we can also create other skills and other intents wherein we can ask it to list all the notes that I have. Then it can say something like, you have 3 notes saved so far, note 1 XYZ, note 2 ABC, note 3 DEF. So that is how you can create a skill that can actually be triggered in your Echo device and finally does something useful and saves some database and data in DynamoDB or something like that. So this is all I wanted to cover as per the creation of the Alexa skill. So let us see how to launch the skill, whatever you have created before I end my talk. So you can simply go to the launch tab and you may have to fill in various descriptions, and you may also have to give detailed description and what are the various phrases that users may want to use to invoke your application or use your application. You may also have to give large and small icons, and once you have all done that, you'll be able to click save and continue, and it will ask for some of other information, and eventually it will take you to a page saying that it is under certification review. So once it goes into in certification, you will not be able to make any changes to your product. So if you see the remember all product, I cannot make any changes to it. So I can definitely open it, but if I try to create a new intent or something, it says that you are being reviewed, so you can't change. So only thing that I have to do is I have to withdraw and then add all the stuff that I want to do, and then I have to ask the Amazon to approve it one more time. So that is how I can actually create an Alexa skill and launch it for the end users to develop. So with that, I don't want to, I did have a few more, but time wasn't enough. So we will have to end it here. So you will be able to read about all the Alexa skill kit, etc. From the link that is displayed. So now let's give a couple of minutes time for any questions that you guys may have. So do let me know if you have any questions. So if there are no questions, probably I can show you a slightly a different thing as well. Okay, let me just, can you create a skill for Alexa that would control some application on the PC or smartphone? Um, Certainly you can, but it's not the skill that's going to do that job exactly the same way. You may also have to have some software on your computer that does it, but you can give those commands through Alexa. The way it works is like this. So you have created a skill which will send some information to the Lambda function. Lambda function will try to make a call to DynamoDB or do whatever it wants, and then it makes another call to another rest endpoint from or some other place where your application on your PC or smartphone will be getting the data from. Maybe whatever notes that we have added, we have created an Android app which will be regularly polling for any new notes that are added for that same user. You can, that application will simply be getting the data from that same table or whatever way you want. So that's how you would do. An Alexa skill directly cannot control your PC or anything, but you can definitely create a client application on your desktop, which will essentially be receiving the request from the Lambda. It can be anything. Yes, you can do, but not directly. Indirectly, yes. Can Alexa control requests to specific web address? So Alexa control, okay, if you're talking about if your Alexa skill can fetch data from some other web address, your Alexa skill will not do that directly. As I was saying, the Alexa skill is all about identifying the intents. The actual crux of your logic is in your Lambda function. So Alexa, what Alexa skill or Alexa service is doing is it is trying to figure out what you have said, and it is trying to map various ways you can tell, and it is trying to map it into one intent which can be triggered on Lambda function. That Lambda function can do that, yes. That is how all the weather report or traffic directions or any flash news or something like that are working in Alexa skill. So the Lambda function will be making that call to the specific web address on behalf of your Alexa skill and sends the data back to the Alexa skill. Lambda function you define as it is defined in Java. I'm sorry, I didn't quite understand the question. We have created the Lambda function. Oh, the Lambda function, I'm not quite sure I understood your question, but what I'm thinking is the Lambdas in Java are different from the AWS Lambdas. So AWS Lambdas are some components that can be used to create serverless applications. Oh, yeah, please do tell me what you mean. Okay. Oh, yeah. I think I'm answering the same thing. I didn't quite get what you meant by that smiley kind of things. Yes, the Lambda functions in Java are not the same as the Lambda functions that you create in AWS. So in AWS, there is a concept called as Lambdas, which can run like serverless applications. So usually, if you want to run some code on some server, you will have a machine where you will have a Tomcat or some or other web server where your application will be running and receiving requests and executing some code and sending the responses back. But there is a concept called as serverless applications, wherein AWS Lambda helps you actually write small pieces of code that will run, but you don't have to maintain whether you can actually create a whether you have you don't have to maintain Tomcat or having a real machine that is actually running the code. So that's AWS Lambda. It's slightly more complex than what I can explain, but it's not the same as the Lambdas in Java. You're welcome. Okay. Before another question comes, I just want to make use of a couple of more minutes that we have. There can be occasions where user may not actually provide the slot information. Something like user may say something like, Alexa, ask demo to remember that, but he will forget to say what to be told next. So he will wait for quite long period of time. And then Alexa can ask, did you forget to tell me what I want you to remember or something like that? And then user will say, yes, please remember, something like that. So we can also build those kinds of slightly complicated workflows in the UI itself. I didn't take you over, but because we have a couple of minutes, I think I can just at least show you where it can be done, even though I cannot exactly show the demo. So if I go to this create note intent, I have the slots here. I can click on edit dialog, and here I can tell if that slot information is required to fulfill that intent. So when we select, we can tell how Alexa should respond. Did you forget? Tell me. Note or something like that. So and user can typically say yes, etc., and then he may give the actual information. So this is how you can configure that kind of slightly complicated flows of whenever a user has forgotten some slot information. So but we will not have enough time to actually build our model and run it, but you can certainly try and give it a shot. I will upload all the code in our in my GitHub repository, which you may be able to find by going to github.com/jbuddha, and you will be I'll create a new repository and upload all the code, and I will try to share that information through the conference. So that's it. Thanks a lot for attending the session, and thank you very much. Bye-bye.